Hey everybody, Mr. Berry here. We're going to be doing an application problem within our total unit on analyzing quadratics. For this particular part here, we're dealing with vertex form for a quadratic function. So we have an application problem here. I'm going to go ahead and take a moment to read it. Hopefully you're able to, in your notes, jot this down. We don't have a graph up here, so we're not necessarily going to be worried about graphing it. However, always a great idea if you can kind of just visualize what's going on in the problem to draw something. So I'll read a bunch of this off. We'll try to draw some sort of visualization of what's going on, might help us out a little bit, and then we'll answer these three questions behind me here. So let me take a moment to step off and read this out loud. A soccer ball is kicked from the ground and travels a path. We have a function right there. H of D is equal to negative 0.025 times the quantity d minus 20 squared plus 10, where the height of the ball, h of d, is shown as a function of horizontal distance in d meters. So we're dealing in meters here. We have the function up there, h of d is equal to negative 0.025 times quantity d minus 20 squared plus 10. Our three questions that we're going to focus in on here is what does the vertex mean? 2, how far does the ball travel horizontally total? And then finally 3, what is the height of the ball when it has traveled 10 meters horizontally? So a lot going on in this problem, very wordy. We do want to take a moment here to kind of just, if you need to reread the problem yourself when you're doing these on your own, please make sure to do that. If you need a moment to kind of annotate the problem, please make sure you do that. So the first and foremost, what I want to check out here is if we could just kind of draw a rough sketch of what's going on in this problem. I'm going to try to put it down here a little bit, so hopefully you can see it on the picture. But what we have here, very simply put, to kind of understand what's going on, is we have a person kicking a soccer ball. There's a terrible drawing of a soccer ball. It's going to go up in the air and come back down. That's what gravity does to these type of things. So this guy's kicking it, and he's kicking it up in the air, and it's eventually going to come back down. All right. So when it comes to this problem right here, this picture should kind of sort of make sense from the fact that we have an a value that is negative. So we have an a value that's negative. It's a very tiny a value, negative 0.025. But because we have an a value that's negative, the important thing to know here about our vertex, which we don't know what it is right here, right now, we do once we look at the function, but we can understand that the parabola is going, parabola is pointing down. So again, our a is negative. So that means we're going to have a downward facing parabola, which means when we talk about our vertex here in this problem, we know that it's going to be a maximum location. Now what I'm going to do with this picture here is kind of just imagine we know that our point value here would be d comma h of d. So if we had to write this out of the point, it would be d comma h of d. Of course, if we were on an actual graph, we would be able to kind of draw ourselves a graph like that. We're operating in the first quadrant. That's a concept from, and I'm writing that off to the side, so let me go ahead and try to put that down here a little bit more. So we're in the first quadrant. Meaning if we had this on a graph, our x values would all be positive, our y values would all be positive. And here in this problem, horizontal distances are d value And maybe I'll erase the parentheses there so we don't get confused later on. And the height of the ball is h of d. Alright, so again, d, just the letter d, is horizontal distance. That's going to kind of act as our x value. And height of the ball is h of d. That's going to act as our y value here. So, in this problem, hopefully we understand a couple things. To start off with, the first question is asking us what the vertex means. We talked about we need the vertex having a maximum. We know that the point d comma h of d will be the actual point location. So I'm going to go inside here to my function. I'm going inside here to my function, and I take a look at this, and I understand that our h value, or in this case the x value for the vertex, comes from what's inside the parentheses there. We have d minus 20, which means for the vertex, I would have to value 20, and my k value for the vertex here would be the number 10. So 20 comma 10 here is my vertex. Just looking at the function, no math work done whatsoever, just being able to point out the information from the vertex and from the function. So right here, that point at the top, because it's a maximum, would be the point 20 comma 10. 20 comma 10. And that's the vertex there. In the context of this problem, since it's a maximum, what that means is that the height of the ball here, the highest it goes up in the air, would be 10 meters. So highest location for the ball is 10 meters. And at that point, the ball has traveled 20 meters horizontally. So the highest spot for the ball is 10 meters. It's traveled horizontally 20 meters. I'll go ahead and abbreviate horizontally H-O-R-I-Z, just so we understand that. So again, going back and answering number one here, what does the vertex mean? Well, we know from our a value we have a negative a value. Vertex is going to be the maximum because we have a downwards pointing parabola. We know that our vertex point is represented d comma h of d, and using our function, 20 would be our d value. 10 right here is going to be h of d. So we know that the highest location for this ball would be at 10 meters, and it has traveled 20 meters horizontally from that. Number two asks, how far does the ball travel horizontally? Total. So we have here our graph, and the ball started off on the ground with the person kicking the ball here, and on our graph that we kind of drew up, that would be kind of the origin. That's the origins of the ball. The ball hasn't moved at all quite yet. We've kicked the ball up in the air, and now it's traveling this distance. We're trying to figure out the total distance horizontally the ball has traveled. So here, I'm just going to mark X as the spot. The ball has finally landed, and it is on the ground again, and we're trying to figure out how much have we traveled horizontally during that time frame. On our graph here, this certainly looks like we've hit the ground, and since we're hitting the ground, that is acting as our x-intercepts, or our roots, or our zeros for this problem. From the start point to the middle, or the midpoint of the traveling of the parabola here, horizontally speaking, it's 20 meters. Again, the vertex here is at 20, 10. Horizontally speaking, we've traveled 20 meters so far. Since the vertex is a midpoint and we have the mirror and we're looking for the other spot when it comes to when the ball has landed, you can go ahead and assume that it will be 20 meters horizontally from the vertex to when it actually lands. So how far does the ball travel horizontally? There's not a lot of math work to be done here because we're going to travel 20 meters to get to the highest location from the kicking spot, and then 20 meters from the highest location until it hits the ground again. So a total of 40 meters horizontally the ball has traveled. How far does the ball travel horizontally total? Horizontally speaking, the ball travels 40 meters total. So from when we kick to the vertex, it's 20 meters. And from the vertex back down to the ground, it's another 20 meters, since that parabola there has a vertex, and the vertex is acting as a midpoint for us. Finally, question number 3 says, what is the height of the ball when it has traveled 10 meters horizontally? So it's being very, very specific here. I'm going to go ahead and underline some things. The first thing I want to understand is that it's asking me a question about height. So when it comes to my two variables in the problem, which one's speaking on height? That's h of d. We're going to go ahead and try to figure out a certain spot for h of d. And it's telling me in the problem that in this case we want to figure out when it's traveled 10 meters horizontally, 10 meters horizontally. So in this case, which one of our variables involves traveling a certain distance horizontally? That's down here. Usually we call that the letter x. In this problem, we're calling it d for how far the horizontal distance is. So in this problem, we're trying to figure out h of d, and we're telling us that d is equal to 10 meters. This one I got to do a little bit of math work in. I got to go back here and use the function that we started off with. I'm going to take d, I'm going to plug it in, and I have to do some calculations here. This will involve the use of a calculator in this case. I'm going to have to pick one up here in a moment. So try not to run out of room here, but let me write down the function that we start off with. And I'm going to take d is equal to 10 meters and plug it in. Wherever I see the letter d, I'm going to go ahead and plug it in. And my hopes for you at this point, when it comes to the solving or calculating some of these functions once we actually have to evaluate some things, is like we talked about in class. Hopefully what you can do at this point is take this whole part of the function here and type it into a calculator. Negative 0.025 times the quantity. We know we can stick the 10 in there for d. Minus 20 squared plus 10. So that's exactly what I'm going to do right now. I actually have to grab a calculator myself. I'm going to type in negative 0.025. I'm going to hit my parentheses buttons, 10 minus 20. I'm going to hit the other parentheses. Hopefully we all aware of the squared button on most of these calculators. And then I'm going to hit a plus 10. I'll hit equals to. And I was able to get all of that in one screen. There you go. Hopefully you can see it right there. And I end up hitting the enter button and I get 7.5 as an answer. 7.5. This is a great time that you can hopefully check out some things. And I have h of 10. About to run off the screen one more time. So I'll go, and we'll go up here. H of 10 is equal to 7.5 meters. How'd I do there? Looks like I'm barely fitting in, and that's okay. That's all right. That should hopefully kind of make a little bit of sense that it's at 7.5 meters. If you go to your graph, 10 is technically in between the 0 and 20 here. So we're probably somewhere at this spot right there. The ball at a horizontal distance of 10 meters is at a height of 7.5 meters. Again, the ball at 10 meters horizontally would be at a height of 7.5 meters. And the question's certainly not asking this, but just to kind of put a little bow on this, we understand how parabolas, vertex, and axis symmetries work. We should know that our x value here of 10 is 10 spots away from the vertex x value, which is 20. It's 10 spots away from our axis symmetry. So it would be fair to say that another 10 spots away would mean right here, when the ball has traveled 30 meters horizontally, the height of the ball would again be at 7.5 meters. It's just this time it would be on the way down towards the ground. So again, just to sum up here, the ball is kicked. We're at 0, 0 when it comes to traveling. The vertex we figured out early on was 2010. A horizontal distance of 20 meters, a height of 10, so the highest location for this ball is at 10 meters. Did some calculations to figure out at 10 meters horizontally, the height would be 7.5 meters. The same could be said about when the horizontal distance is 30 meters as well, because of the different things that we know about parabolas.